Greetings, programmers. We have two functions left to build: the find friend and down ramp diagonal, and find friend and up ramp diagonal. So when we take a look at, any one of these queens, we need to find if they have a friend in the down ramp or the up ramp. The down ramp is a little bit easier because the down ramp is built in the same way that we count with our arrays. So we start with 0, 0 up here and end up with 7, 7 down here. Or in row 7 here, column 0. So that's 7, 0. So we can use that to our advantage in our code. So let's use that one first, the up ramp diagonal. We want to see if we find a friend, or excuse me, in down ramp. So we want to see if we find a friend in our down ramp diagonal. So let's make a bool for friend found, and then let's return friend found. And so we'll start off saying, nope, we haven't found anybody, and we won't mark that as true until we actually find something. When we take a look at these queens, the way I want to approach this is I want to find the top of the diagonal and then search each of the blocks or squares in that whole diagonal. So what I'm going to do is I'm going to find the distance from my queen to the top of the diagonal and then start there and go down. So my first step will be to find that distance. Int distance to top of diagonal. And I can use math.min. The reason is wherever I am here, the smallest number in my coordinate system is is as far back as I can go to get to the diagonal. So because I have a 0 in this coordinate, I can only go back 0, right? I can't go back any to find the top of that diagonal. If I'm in this location, which is 0, 1, 2, 3, 4, 5, and 0, 1, 2, 3, 4, 5, 6, so 5, 6, then I can take that smallest number, 5, and I can go back 5 to get the top of the diagonal. 1, 2, 3, 4, 5. You can take several other examples and prove to yourself that is going to work. So I can take the minimum of the row and the column, and that's going to be my distance to the top of the diagonal, which means that my start row will be my row that I pass in minus the distance to the top of the diagonal, and then the start column will be whatever column I started with minus the distance to the top of the diagonal. And now I can create a for loop to go down the diagonal, not to walk through the array. See if this makes sense to you. So I'm going to go while int, and I'll call this thing diagonal. And I'm going to start at location 0 on the diagonal. And I could go with two different ways on here. I'm going to just say I might go the maximum distance here of the 8. Now to put in a plus plus. So now I need to get the actual location I want to check. So that's going to be, I'll use R for this one. That's going to be my start row plus wherever I am on the diagonal. And then the column will be my start column plus wherever I am on the diagonal. Right? So if I started out here, I want to add 1 and add 1 to get there. Right? Add 1, add 1. But so now I can check to see if the chessboard at R comma C has a Q in it. But I not only need to do that, I also need to check to see if I am at the location where of the queen that I passed in, which would be in the case that R equals row and C equals column. If I am there, I did not find a friend. So when I check that location, I want to make sure that did not happen. So assuming that I'm not on my passed in queen, that means I did find a friend. But I don't want to assign the value like I've done before. I want to OR it with true. So once I find a friend, I never want that to go back to false. Once it's true, I want it to stay true. But now I also need to make sure that I'm inside the chessboard. So I have a little function here that will do that for me. It makes sure that the row is between 0 and 7 and the column is between 0 and 7. And if it's not, then this returns a false. If it is, then that says, hey, you're still on the chessboard. So I want to I'm going to have another Boolean variable. I'll call it inside chessboard. And I'll start that off with true. But then at the end, when I get down to the end of my loop, I want to say inside chessboard equals that function. For not the row that I'm on now, but the next one. I want to see if the next location is going to be inside the chessboard. Because if it's not, I don't want to go through the loop. Right, if I started here and I go 0, 1, 2, and then I get to this location, I don't want to keep going until I check all 8 of those blocks. I want to realize, hey, I fell off the chessboard and I want to stop looking. So that's what I think this will do. Let's see if this code works. Ampersand cannot be applied to operands of bool and int. R equals row. Oh, I did an assignment there. Can't do assignment. Need to do comparison. So this took me to 1,000,000. So I have an error going on right now. Let's come back. Let's see. I think I might have made a change previously. So let's make sure that we're placing queens randomly. Oh, I didn't change it over here. I still have that same error because I didn't make the change on this side in this editor. Now when I paste it into my running editor, it says we found a solution, but I want to make sure that we don't see any down ramps. See a lot of up ramps. Is that one? No. I think that's okay. But what we can do is we can use our testing code that we've used before. and create an unsafe board with a down ramp. So this has a column also. So I'll remove that. So now I got to move this one. So now if we create an unsafe board at the end when we build a board. So yeah, it is not letting that pass. So I believe we have our down ramp fixed, our down ramp complete. So we can mark the down ramp diagonal as complete. And then I need to go back and don't create the unsafe one anymore. And now this should work over and over. No down ramps, right? At least if we do find a down ramp, we'll know exactly where to go and start looking.